Well, I'd like to say thank you to the group for inviting us to present our results in this forum. And I'd like to thank my co-authors on this project, as it was a lot of hard work for all of us. So I'm going to talk today about the in situ assessment of lampricide toxicity to age 0 lake sturgeon. And just to give you a bit of background, as most of you in this room know, TFM and TFM 1% niclosamide is the key component of sea lamprey control in the Great Lakes Basin. And we know since the development of TFM and the addition of TFM 1% niclosamide that non-target fishes demonstrate a wide range of sensitivities to TFM, and there are concerns in particular about age 0 sturgeon being susceptible to lampricide. So the main reason that this came out was a study that was published in 2003 where controlled studies showed that age 0 lake sturgeon, which are generally under 100 millimeters in size, were susceptible to TFM and TFM niclosamide at fairly high rates. So that had great implications for sea lamprey control due to the conservation concerns for lake sturgeon in the different areas in the Great Lakes. So in response to this, the control agents developed what was called the Sturgeon protocol, and that limited the application of TFM to a concentration of 1.2 times the minimum lethal concentration that's required to kill sea lampreys, and moved the timing of the application until after lake sturgeon were expected to be over 100 millimeters in size, which based on the models that were developed was after August 1st. Now there were some concerns about that, particularly in Lake Superior streams that were colder, that perhaps we weren't meeting this size range until much later than that. But this also led to the concern that this may be actually increasing some of the sea lamprey levels in the Great Lakes due to the application of the Sturgeon protocol. We do know that using the protocol, we are cutting in some areas the TFM application to about 1.2 times minimum lethal, so it doesn't leave a lot of range. We may end up with more residuals left in the streams. And also moving treatments later in the year, we do know that in some cases larger lamprey tend to be more resistant to TFM, so we may have more survival that way as well. So in 2008, we actually set out to test the in-stream survival of age 0 lake sturgeon, subjected to both the regular treatment protocol and to the new sturgeon treatment protocol using TFM and 1% niclosamide. And our hypothesis when we set out to do this was that sturgeon less than 100 millimeters were going to be affected by TFM, but we expected that there was going to be better survival under the Sturgeon protocol. And we did this project in the Mississauga River because it allowed us to use 2 different TFM concentrations in the same year. So the upper half of the river was treated following the Sturgeon protocol, which was the 1.2 times minimum lethal, and the lower half of the river we treated using the normal treatment protocol of 1.5 times minimum lethal concentration. Now what we found, the methods that we used hatchery-reared age 0 lake sturgeon, which was the same strain that was used in the original study in 2003. For our treatments, we used 15 cages in each of the 2 sections of the Mississauga River, and we had 5 fish in each cage. And we had a control section with 10 cages, and we used 5 fish in those cages as well. So what we found was we actually had no difference in survival between the control and the upper Mississauga, which was treated at the 1.2 times minimum lethal, and the lower section, which was treated at 1.5. And our survival rate was 93 to 94% survival for the sturgeon that were less than 100 millimeters. The mean size that we used in all 3 sections was 78 millimeters, and our size ranged from 57 to 100 millimeters. So again, they were all within the area that was expected to have very high mortality based on the studies published in 2003. Now one thing you will notice, this was the control section here. This section was the 1.5 times minimum lethal, and this was the 1.2 times. We did have sturgeon that perished that were in the smaller size, but again, we also had survival at this range as well, so it wasn't entirely just small fish that perished. So the big question that came from that was the Mississauga River an anomaly, or is there something else going on that was the difference between the lab studies and what we're seeing out in the wild? So between 2010 and 2011, we expanded this study. We used 9 different tributaries for a total of 10 treatments. And we used a mix of tributaries from Lake Huron, Michigan, and Superior just to move around the lake. And we also looked at the difference between TFM and TFM 1% niclosamide treatments. And we used the same strain of hatchery-reared sturgeon that we'd used in 2008. So the study rivers that we used, we had 4 in Lake Superior. We had 2 at the upper end here, the Kaministiquia and the Whitefish. the Batchewana, and the two-hearted. We used 3 on Lake Michigan, the Millicockins, the Sturgeon, and the Pigeon, and we had 3 streams on Lake Huron. So we had the Mississauga again, and actually the Rifle River we divided into 2 sections. The upper half we treated with TFM only, and the bottom half we treated with TFM niclosamide. And we followed the regular treatment schedule of July to September, so we didn't adjust anything that way. For the methods, we actually repeated the bioassay study that was used for the original 2003 work. We did the bioassays on-site using an on-site bioassay trailer, and we had 9 of those. So we had the age 0 lake sturgeon exposed to concentrations ranging from 2.1 times the minimum lethal concentration to our control of 0, and there was 10 concentrations in total. And then again, we repeated the in-river portion. We used 20 cages spread throughout the treatment zone, and then we had a set of 10 cages for control. So for the bioassay, we put the fish into the bioassay tanks 24 hours before the treatment. They were exposed to the treatment for the 12 hours, which is generally the standard for in-river for the full treatment. And then we had 12 hours of clean water after. The tanks were checked hourly for mortality. Any were removed, they were measured and weighed, and then at the end, all live fish were also removed, measured and weighed. And after that, for one of the rivers, we held the sturgeon for an additional 30 days back at the hatchery after, just to follow for any additional mortality post-treatment. So for our results, what we found in 2010, we did 4 bioassays, and what we found, based on what was expected from the original work done in 2003, we actually had very high survival. Our survival ranged from 80 to 96%. So again, for fish that were smaller than 100 millimeters, we had very good survival rates compared to what had been predicted from the work in 2003. Again, we used fish that were smaller, mean size than the 100 millimeters. We did have a few fish that turned out to be a little bit bigger than that in the cages, but overall our mean size was less than 100 millimeters. In 2011, we again repeated the bioassay portion. We had 5 bioassays this time. We did have more variability in 2011. Our predicted survival, now this is for all concentrations, so for the 2.1 times minimum lethal through to the controls, our percent survival ranged from 51% in the Rifle River, which was both the TFM and TFM 1% niclosamide, through the Pigeon at 60%, and then 80 and 86%. Now, one thing to note, in the Mississauga River, our fish were actually quite a bit smaller than what we'd actually even anticipated using, but due to the timing, we used the fish that we had. So we had fish as small as 32 to 46 millimeters used in this, and we still ended up with an 80% survival. So again, much higher than we expected due to the work that was done in 2003. So then we wanted to compare this to what we were actually finding out in the river. And the bioassays were conducted within 7 days prior to the in situ treatment, so we didn't have a long delay between the two. And again, we placed the cages out in the river 24 hours prior to the treatment. They were left in for the treatment, and then held an additional 24 hours in the river post-treatment. So we had an average of about 60 hours for each cage to be out in the river. Once the treatment was completed, all the cages were picked up, the sturgeon were noted whether they were live or dead, and all were measured and weighed. So in 2010, we had 5 in-river treatments. Based on the predicted results from 2003, we had expected, again, potentially lower mortality. We weren't sure how it was going to compare with what we'd done in the Mississauga, but what we actually found was, again, much higher survival than we originally expected from the 2003 work. Our survival ranged from 80 to 100%. So again, we had much higher survival than we had originally expected there. And in 2011, again, we did another suite of streams, so we had 5 more treatments that we completed. We did have more variability in 2011. On the Pigeon River, we only had 45% survival. The Rifle River, we did better than what was predicted in the bioassays, but again, we did have rivers with 82 and 88% survival. And again, you'll note on the Mississauga, we had very small fish that survived the treatment, 35 to 47 millimeters in size. So again, almost half of what we had expected for size range based on the 2003 work. You'll also note in the Mississauga in 2011, we didn't have any controls that survived to compare to, unfortunately. We had vandalism on the stream, and we lost 4 of our cages. And in addition to that, the area that we placed the controls was a regulated portion of the river, and overnight the river dropped over a meter and all the fish were exposed to air, so they didn't survive. So based on this, our results summary, the bioassay survival rates, again, this is for all concentrations from the 2.1 times minimum lethal down to our controls. Our predicted survival was 51 to 96%. And our mean survival size ranged from 49 to 99 millimeters over the 9 bioassays. So again, this was actually, again, better than what had been predicted based on the 2003 work. And when we look at the bioassay survival rates for 1.5 times minimum lethal, which is what a normal treatment is run at, that rate improves to 68 to 100% survival in the bioassays. What we also found was we did not have any latent mortality for the sturgeon that had been exposed to TFM and were held for an additional 30 days. So it does appear that if there's going to be mortality, it occurs during the treatment, and the fish after that feed normally and continue to grow, so we don't seem to have any latent mortality. For the in situ work that we did, we found our survival ranged from 45 to 100%. So again, we do have some variability on some of the streams. And our mean survival size ranged from 42 to 121 millimeters over the 9 treatments. So in summary, what I have is sturgeon that were less than 100 millimeters in size. Our survival was higher than what was predicted by the original work done by Bogart et al. In 2003 in both the bioassay and what we're finding on the streams. Now, there was variability in the survival between the rivers, but overall our survival was quite good. So 9 out of the 10 rivers we had survival that was greater than 63%, and in 7 of those we had survival that was greater than 100%. So what that leaves us with is the question of, is the small mortality that we found in the study in both the bioassay and in situ, how does it compare significantly in the context to a sea lubricant treatment program that runs on an annual 3 to 5 year basis for some of these streams? So how does that compare for what we're looking at compared to the treatment schedule? So with that, I'll take any questions.